The things that I'm going to drill down to now, and hopefully when we're done, all these topics combined as well as the subtopics will help us come up with a good definition of what it means that something's enterprise ready. And when somebody asks you, well, is this product ready for your enterprise? If your enterprise follows this diagram, you can pretty well say yes or no, it fits this litmus test. So, all right, next. Okay. So the first topic here was the service level agreement. I've also used this category to kind of lump in other topics that didn't fit into my other categories because they would pop in my head and I didn't have time to create another subtask for them. So service level agreement is an agreement between the provider and the customer, and basically you're promising or guaranteeing some level of service, whether it's a number of process, performance-based service level agreement, application availability, access to your help desk, you name it. There's all different parts of your service level you provide for your customers. So I think to begin talking about enterprise, you have to start here because everything you do in your enterprise is based on what you're doing for your customers. So I've outlined a couple of other questions that you might want to think about. 800 numbers, remote access for your admins, remote access for your customers, escalation procedures that need to be outlined. This is one of those categories I just threw in there. If you have a problem in one area of your enterprise, you've got to have a clearly defined escalation procedure for resolving that particular problem. You can't be in a situation where you don't know what to do. Because if you have an area where you don't know what to do, then you're in clear contrast to some service agreement that you have. So, and also consider how many machines, and in addition, I put the last comment in there, this lights out management adapters. That's mostly a PC term. I don't know if you're familiar with compact hardware or IBM hardware. They tend to sell PCI cards that you would stick in. They kind of substitute your keyboard and mouse and monitor and allow you to tell it in there and basically manipulate the box as if it was local, kind of a PCA or a hardware solution. So, just some things to think about. All right, let's go to the next one. Availability. This is probably the most important category when you talk about SLAs. You're going to promise that your equipment is available X amount of hours a week, a year. I have the infamous nines up there. A lot of companies consider 5 nines to be good uptime and availability. That's 99.999% of the time. And I don't remember what the actual numbers boil down to.
5 minutes down.
Yeah, so 5 nines availability is like 5 minutes of downtime for an entire year. 6 minutes. Is it 6 minutes?
No, 6 nines.
6 nines is 5 minutes?
5 nines gives you almost a day's downtime.
Days down. Okay, great, thanks. Everybody hear that? So 6 nines is 5 minutes, 5 nines is almost 24 hours. Like that? All right, so that's the availability piece of it. And when you talk about availability, obviously you can break it down to actual server availability or application availability. Some applications are easy to switch from one physical system to another, especially if they're available on your network. So your customer sees almost no downtime while something fails over to another box. This is where you get into system clustering and that kind of technology. And then, of course, another piece of your availability is identifying all your single points of failure, otherwise known as the spots, and also having a good risk assessment and management team. Traditional techniques for improving availability. Number one on the list is, climate-controlled data centers, things that help your hardware live longer. Redundant power supplies or redundant hard drives and batteries and generators. There's any number of things you can do to help your system stay up longer. Unfortunately, every time you add another layer of redundancy, you're usually upping the cost of the hardware that you're purchasing. Server class hardware with redundancy, again, this is the hot swap disks, power supplies. Even now you've got the hot swap PCI cards. So if your network card fails, newer systems allow you to actually take that slot offline. You can replace the card while the system continues to run. And clustering technologies like, let's see here, Yeah, clusters. That's what I was mentioning before. Applications can work between one box or the other. So there's any number of software solutions to automate that process where if you know a system's failing and you have to take it down for service, you can do a little point and click and migrate the application off of one system running on the other. HTTP, Apache is a perfect example. Doesn't matter which box it runs on as long as the configurations are pretty much identical. And then you can fail the IP address from one machine over to the other. And customers don't see any interruption in service. HA software, this is a high availability software, usually employs some type of special communication between two boxes so that they monitor each other's health. And if one box knows the other guy just panicked and failed or crashed, then the other system only has to start the application. It doesn't necessarily have to reboot the entire machine. So if my box over there has a CPU failure or something of that sort, the system over here will notice that, come up, bring everything online, and again, everything happens within minutes or even seconds, and the actual outage to a customer is very minimal. Veritas, a local company, has a clustering product called VCS, which is pretty popular. I think Legato has another one that's pretty popular, and of course, IBM has their HACMP stuff for R6000s. None of those are available for Linux, except for VCS, which is almost out the door. Okay, and then the last piece here, an important technique for improving availability, obviously, is to hire, train, and retain responsible, capable employees. You can hire all the great employees you want, but if you can't keep them, then that turnover process really kind of puts your availability in jeopardy, because you lose somebody who knows your environment. If the problem does happen, you might not have the new hire in a position where you can actually deal with the problem. All right, next. All right, the performance and scalability section. Talk about enterprise computing. Consultants come in and they give these great, big, wonderful, presentations on scalability. Basically, it breaks down to two terms. One is vertical and horizontal. Vertical scalability, in a physical sense, is more CPUs per system. You've got one application, like a database server. Databases don't do so well when they're distributed across 5 servers, or especially if you've got one big database, it's hard to take it down from one system and switch it over to another. So basically, when you talk about vertical scalability, you want everything in one big box with as many CPUs and as much memory as you can have. This adds to very complex hardware, complex software. For those of you who don't know, Linux still has a small problem with scaling to a large number of CPUs in a linear sense. That's probably the next topic down there. Is often measured in terms of linear scalability. This is a pretty simple formula that basically measures the actual system performance versus the number of CPUs you have in the box. So if you continue to add new CPUs, you double, add another 25% of raw processing power. And Linux, even with the 2.4 kernel, pretty much scales about 4 CPUs, but even then it starts to tear off. And the more CPUs you add, you're not necessarily getting as much bang for your buck as you should. And then the last comment here is obviously that there is a limit. Whether it's a hardware limit or a software limit, you can only add so many CPUs to your box, and at some point you're not going to get any measurable gain out of it. Another consideration when you're talking about vertical scalability is some applications don't thread well in an SMP environment. Adding more CPUs to an application that's not threaded doesn't help you because it's going to get locked on one CPU and just keep running that. So that might be a perfect opportunity to do a horizontal scale, which is having multiple number of boxes running your application. You consider like an Apache web server or something, or like a web server farm like Slashdot. They've got their, I don't know how many servers they have, but they've probably got more than 2 servers running Slashdot. Yet to you, when you connect to the environment, you don't know, you think you're connected to the same box. But on the back end, they've got the application spread out across any number of systems. And this is where Linux really excels. Because Linux is low cost, runs on low cost hardware, it's easy to put up 20, 30 boxes and scale your application across the system. And performance is achieved through network infrastructure and application design. There's a number of products you can purchase. I think there's one called Big IP or something like like a hardware front end you put on your network, and it basically does the load balancing for you. So connections for your website come into this big IP box, and then it kind of round robins through all the systems that serve up your web server, and it does that for you. So now there's really nothing on the OS side doing this. All the intelligence is built in on these little proprietary boxes. And I think there's also some solutions which actually run on Linux, like was it Piranha, something like that. Does the same kind of thing. You know, you have a number of Apache web servers running behind the central node, and then the load balancing across those. One of the things you might run into with horizontal scaling is access or shared access to read-write data. Perfect case is a database. In an Oracle parallel server, you can have multiple Oracle servers accessing shared data. But unless you're a big shop and you can afford the cost of something like that, you're probably running one database which has a read-write lock on your data, and maybe some other databases that have read-only locks. But again, you have to face that problem of how do I share the data across that many systems. Consider NFS might be a good solution. Performance isn't all that great. There's other intrinsic problems with NFS. And of course, it's always important to identify all your single points of failure. Yes?
With NFS, which apparently doesn't scale all that well, you start putting upwards of 11 or 12 boxes on it, and you end up, by definition, ending up with blocks. Is there any other solutions? I looked at things like Intermute and ASS and things like that, and none of them seem even as robust as NFS. Do you know of any?
I do not. No. There's the Linux Global File System project, but I don't know where that's going.
Check out the Sistina website where the logical volume manager is. They've got a global file system project that I don't think it's there yet, but I think it's on the way.
SISTINA.com.
I'll write that up on the board. The question was, how do you deal with shared data if NFS isn't really an option for you? The comment was made that NFS really doesn't scale well past 11 boxes. We just put our And basically the response was, I don't really know of any open source solutions, and even in the proprietary world, I don't really know of any awesome solutions. But you could consider something like a network appliance with multiple network interfaces. That might work well for you. Or simply putting multiple network interfaces on a single box. I really don't know. So, okay, that's the Sistina website, so there's the global file system. And of course, when you talk about enterprise computing, you're oftentimes connecting your boxes to what's called the SAN, or Storage Array Network. Is anybody not familiar with what a storage array network is? Okay, real quickly, it's kind of like NFS, except it's all implemented through a proprietary fiber channel link that basically puts network storage on a network. It's block level. It's a block level device. Basically, you put these giant silos of disks on a wire, and then you share your boxes by connecting them to the SAN. So you don't have any locally attached storage. You can have all of your SAN disks in a completely different room or even a different location. And then, provided the SAN can extend into your data center, you can just have rack of systems that attach to the SAN, and it's all the same concept. They've got fiber channel switches and hubs, things that help segregate traffic on the SAN, and also help boxes that you've got a giant silo of 1,000 disks. You don't want your system seeing 1,000 disks because every time it boots up, it's got to go down the protocol. So they have all that in the SAN architecture, which is mask, LUNs, and do all that kind of business between boxes. So same concept as local attached storage, except it's managed differently. Okay, let's get back to the screen here. All right, and identify your spots. Okay, next. Monitoring. In any enterprise, you really need to know what's going on. And you can't be caught off guard where your system's been down, especially if you're promising that your system's going to be online at a certain amount of time throughout the year. Comment that I've run into most is, a lot of enterprise shops who have been around for 10, 20, 30 years or more, they're not going to remodel the process that they've developed over this year, all the knowledge base that they have just to run a Linux box. So, you kind of have to think of this when you consider whether Linux is enterprise ready. Linux might be ready for its own